Now that we have a good feeling about the product rule and what exponents mean, we can move on with a couple other rules. Now, one of the big things we were talking about was what operations really are. Multiplication is repeated addition. Exponents are repeated multiplication. So we're building rules off of those ideas, and we learned something pretty big last time. One of the big things was what we actually do with the exponents is one operational level below what we see on the paper. So if we see multiplication, we are adding exponents. If we see division, we will be subtracting. If we see addition, subtracting, or addition or subtraction, nothing. There's nothing below that to do with exponents, which is why they would have to be the same. And we'll cover that in a couple more videos. Now we move on to something else. Suppose that we see exponents being raised to other exponents. We see an exponent operation. What in the world are we going to do with that? Well, let's discover it. Let's really think about what this means. What exponents mean is repeated multiplication. So if we see 5 to the third being raised to the fourth power, well, what that really means is 5 to the third times 5 to the third times 5 to the third times 5, 4 times. We have repeated multiplication with exponent. That's already annoying to write. I don't want to do that a lot, especially if I have like 5 to the third to the 41st power. I mean, are you kidding me? I don't want to write that out 41 times. It's crazy. So let's find a better way to approach it. 5 to the third to the fourth power means 5 to the third multiplied by itself 4 times. That's repeated multiplication. However, we've already done that. That's the product rule. That says, wait a minute, if I have 3 fives multiplied, 3 fives multiplied, 3 fives multiplied, 3 fives multiplied, I'm repeatedly multiplying the same thing over and over and over again. We could just add up the number of fives that I have. So wait a minute, repeatedly adding the same number, well, that's multiplication. So if I have 3 plus 3 plus 3 plus 3, that's what we could do, right? I mean, that's the last video. 3 plus 3 plus 3 plus 3, that's adding 3 4 times. That's 12. Well, wait a minute. If I'm always going to be getting back 5 to the third over and over and over and over again, won't I just be adding the same number over and over and over again? That's repeated multiplication. That's repeated addition. That's multiplication. So when we see exponents being raised to exponents, we're going to do multiplication because we'd be repeatedly adding the same number. What we do with exponents is one operational level below what we see. If you see exponents on the board, what we're going to do with those exponents is actually multiply. If you see the level of operation of exponents, we're going to be multiplying. Isn't that interesting? It's always one level below what you see. In general, that's the way it works. If we have exponents that are raised to more exponents, so we have the level of exponents operationally, we're going to be doing with those exponents one level below what we see. We're going to be multiplying those exponents. And it's pretty quick, no matter what your base is. Now notice something, this is important. Your base doesn't change. Your base is inherently taken care of when you actually go and do the operation. So 5 to the third to the fourth, you're still going to have 5. You don't go and go, well, now I've got 20 to the 12th. Well, that's crazy. That's crazy. Exponents inherently multiply that base over and over and over again. So if you were to take that 4 and multiply to 3 and multiply to 5, that is not what we're doing with these exponents. That 5 gets multiplied in the process of having an exponent. You don't need to multiply it by an exponent. It's already been multiplied a lot of freaking times, all right? You have to do that. Nothing about this changes the base. Exponent rules apply to the exponents, not to the bases. So we can do some pretty quickly. Our base here is 2. I'm looking at it, I'm thinking, well, I've got a base. I have the level of operations. I'm seeing a level of exponents. That's the operation I'm seeing. What I do with the exponents is one level below what I see. So if I see exponents, I'll be multiplying. Notice how big that number gets. I mean, that's way more than 40. We're not multiplying that way. 2 times 2 times 2 times 20 times? That's crazy. That's a huge number. Try it if you want to. The little button on your calculator usually looks like this if you have Texas Instruments, or like this on some older calculators, or like that. Don't do this one all the time because that's just a power 2. Your calculator can't read your mind. So when you put, I'm going to put that one and mean to the 5th. It doesn't know that. So that only squares numbers. So try that. Try 2 to the 20th. See if your calculator has enough screen to even put the number up there. It's crazy. Some of these get very large very quick. We can do the same operation with variables as well. I mean, hopefully you understand that that is a variable. B could be anything, including other variables. So when we have exponents on the paper, what we're doing with those exponents is one operation level below what we see. When we saw multiplication, we were adding. When we see division, we'll be subtracting. When we see exponents operationally, what we're going to be doing is one level below that. We'll be multiplying. You could write it out still, couldn't you? You could write out x to the 5th times x to the 5th, do it 9 times. Extrapolate from that 5x's times 5x's times 5x's 9 times and add them all up. You're going to get 45, but that's a lot of work. That's breaking it all the way down to just counting up numbers when we could be using repeated addition as multiplication. That's what we're doing here. This would be x to the 45th. Of course, the biggest thing people do is get confused and say, oh, I don't know when to add and when to multiply. Is that 14 or is that 45? That's why I'm telling you to look at the operation. What we always do with exponents, one level below what we see. If you see a level of exponents, multiply. If you see a level of multiplication, add. If you see a level of addition, nothing. That's the way they work. Now, there's 2 other rules that we're going to talk about. The first one, and they're basically the same rule. I briefly mentioned, it's such a huge deal, but I briefly mentioned it last video. Here it is. You can distribute also one level below what you see. A lot of our exponent rules are one level below what we see. So you can distribute exponents, but only across one level below. So if we see exponents go, okay, I want to distribute that. Sure you can. Across multiplication. Absolutely across division, which is what fractions are, but never across addition. That's 2 levels below. So are you seeing what I'm talking about? When I'm talking about distribution here, distribution of exponents can happen across multiplication or division. That's 1 level below. This is 1 level. To addition subtraction, that's a no-no. You cannot distribute exponents to more than 1 level below. That's actually the way distribution works in the first place. If you were to distribute multiplication, which is what it is, you can distribute multiplication across addition or subtraction. You can distribute multiplication or division across addition, subtraction. It's always 1 level below anyway. You've done it for years. But now we're talking about exponents. So when we move up a level, you can't distribute across addition, subtraction anymore. That's 2 levels higher. You can't do that. You can only distribute to 1 level below what you have. We can distribute multiplication across addition and subtraction. You can distribute division, that's fractions, across addition, subtraction, but we can't distribute exponents across addition, subtraction. This will never distribute across here. It won't work. It's 2 levels below. Are you seeing what I'm talking about? Multiplication, sure. 1 level below that's addition, subtraction. Exponents, no. 1 level below that is multiplication, division, not addition, subtraction. So can we distribute exponents? I always tell students no, frankly, because they always think it's addition, subtraction. But the answer is yes, if you're talking about multiplication, division. 1 level below exponents. You can always distribute 1 level below what you have. So can we distribute exponents across multiplication and division? Yes. Do you have any multiplication? Of course. Now, one thing that I'm going to tell you is that this is a combination of 2 ideas. It's a combination of distribution. It's also a combination of the power rule, because every single one of these factors has an exponent. So when you get this, you go, well, how do I find my exponent? Is it magic that it's a to the nth? No, it's not magic. When you start distributing, just like we did in the last video with multiplication, you added the exponents. Do you remember that? Last video, last couple examples. We distributed. Because we were distributing, we saw multiplication. Because we saw multiplication, what we did with exponents is we added them. Well, we combined 2 ideas, a multiplication idea and a distribution idea and an addition of exponents idea. Same thing happens here. We're combining a distribution idea, this idea that you can distribute one level below what you see. We're distributing exponents across multiplication. But it's also this idea of when you do that, you're applying exponents to exponents. You have the power rule. We have an exponent raised to an exponent and another exponent raised to an exponent. What I do with that is I have to multiply those exponents. So again, can we distribute exponents? Yes, across multiplication or division. When we do that, we're also taking an exponent to an exponent. So this is a to the, let's see, I'm seeing exponents, I should multiply a to the nth. I'm seeing exponents, I should multiply b to the nth. That is the way the exponent rules work. With those kind of three rules, you pretty much get to do all the exponents for a long time. Keeping in mind that what you do is one level below what you see. What you distribute is one level below what you have. It's always like that. It's pretty cool because that sums up everything you need to know in one statement. Same thing works here. Because we have exponents one level below that is multiplication, and it also includes division. So we can distribute exponents across division, but notice how it still has the same combination of two rules idea. I'm seeing exponents, I should multiply. I'm seeing exponents as a level of operation, I should multiply. Now, we're going to practice just for the next 5 examples. They're going to be quick. This stuff is relatively fast. Here's some key points though. Number one key point. Show every product, because if you're going to be distributing exponents across multiplication and division, you need to identify all of it, because distribution goes to everything. If you were to distribute across like 4 terms and only go to 3 of them, you'd have a big problem. We are distributing exponents across factors now, stuff that's multiplied. We're distributing across factors. You need to show all of the factors. So here I have 2 factors. Now, the way that exponents distribute is by affecting exponent rules, affecting that power rule over and over again. So, excuse me. So every single time that we have a factor, we're going to have exponents up there. We got to have that. So when we start distributing exponents across factors, across multiplication, across division, every one of those factors has to have an exponent. Remember, we're about to use the power rule in this distribution concept. So when we distribute, you got to show all the factors. Everything's multiplied because it has to go to everything. How it goes there, how it gets applied to those factors is through the exponent rules. So we go, okay, well, 4 to the first, that's going to get that exponent. How? Well, I'm seeing exponents. I've got to multiply. 4 to the 3 times 1 is 3. Notice what I'm not doing. It's a huge problem. I see it all the time. What I'm not doing, I'm not multiplying 4 times 3. That is not the idea. That's not what we're doing. Exponent rules can only apply to exponents. That's why we give it an exponent. Next up. X to the first to the third. So we've distributed to all, everything is being multiplied. You can always distribute one level below what you see. So we see exponents, we're trying to distribute that. It distributes across multiplication, goes to every factor. How it does it is through multiplication over exponents. Powers raised to powers, you're multiplying. That would also be x to the third. Now if you want to keep on going, 4 to the third is 64. So you can simplify it even further than that. Next one, so let's take a look at it. Oh, what's the 5 doing? There's no way that 4 should go to that 5. What is happening though, I want to distribute my exponent of 4. I can only do it across one level below. So I see multiplication, I want to show the multiplication. Now, I'm looking at it going, well, that already has an exponent, that's great. That already has an exponent, that's great. So as far as dealing with my exponent rules, I don't even look at the 5. I don't even care about it right now. It's just going to stay there. So I'm going to have, well, let's see. That exponent is going to distribute across multiplication. That's fine. And the way it does it, well, when it distributes, I'm going to have an exponent raised to an exponent. I'm seeing the level of exponents. Are you seeing what I'm seeing? I'm seeing that. If I see exponents, the level of exponents, what I do is one level below. I do the multiplication. 2 times 4 is 8. Again, for the y, 2 times 4 is 8. Now that 5 out front, That's just a multiplication concept. It has nothing to do with exponents. There's no exponent rules I need to do anymore. Maybe make it a little simpler. 5x to the 8th, y to the 8th. That's the idea. I hope you're getting it. We only have a couple more here, and then the last one's got a special one. But I need to show you what happens with that negative as opposed to that negative. I'm going to give you a special way because they can be very, very tricky. A special way to do this. Here's how I'm going to approach this. Instead of thinking of this as -3, what I'm going to choose to do I'm going to think about this as -1 times 3 times x to the 4th. I'm doing that for a reason. All raised to the 3rd power. Now we know this about exponents. We can distribute as long as it's across multiplication or division. So I've shown all my multiplication. In fact, I've shown this -1 out here. I'm going to show you why that's important by comparing it to this problem. Now, I'm going to give everything an exponent. Even my numbers, even like we did right here. I'm going to give this a little power 1. I'm going to give that a little power 1. Because every single one of those factors is going to get that exponent distributed to it. We're distributing exponents across multiplication, but how we do it is through the exponent rule called the power rule. Well, now I have -1 to the 1st, but in order to get that, I've got to have the 1 times, I have to have the 1 raised to that 3rd power. Why we put the 1 is so you don't accidentally multiply these numbers and give me -3 and give me 9. That's not the idea. The idea is our bases stay the same. Notice that. Bases stay the same, bases stay the same, bases stay the same, bases stay the same. Our bases, yes, we're doing exponent rules. Yes, we're distributing across multiplication. But when we take exponents raised to exponents, we're multiplying the exponents only. That gives us -1 to the 3rd. It gives us 3 to the 3rd. It gives us x to the 12th. We've distributed across multiplication to every factor. That's how distribution works. It goes to everything. We can distribute one level below what we see. I'm saying that a lot to pound into your head so you never forget it. After that, I'm taking exponents to exponents. I'm seeing exponents. I multiply exponents together. Don't do anything with the bases. After that, now we can start simplifying. -1 to the 3rd power, 1 times -1, that's -1, times 27 times x to the 12th. That's -27 x to the 12th. Ran out of room. I forgot my problem. Here's why we do that. Why I don't just have you say, oh, well, it's this to the 2nd. I talked briefly about how when you have exponents, if there's no parentheses, that negative does not go with that exponent, and it doesn't. So to save ourselves a lot of headache, we separate that negative. And what we do is we allow that to be its independent factor. It's separated from it. That's great. That's going to make your math a lot easier. So I know I can distribute that exponent across multiplication. I just have to show it. So to show it, I'm going to think -1. I'm going to think 3 to the 2nd, y to the 3rd, and then all of it squared. I really have three factors in here being multiplied. Y to the 3rd, sure, I can kind of see the multiplication here. 3 to the 2nd, that negative can be separated. If it's not in parentheses, together with this, I can pull out and make it -1. That's got an exponent, that's got an exponent, this needs an exponent. So now I have 3 factors in there. I can distribute exponents across multiplication. So I'm going to put it to all 3 of these. How I do it is, well, I have now exponents being raised to exponents. I'm seeing a level of exponents. One level below that is multiplication. What we do with exponents is one level below what we see. So I still have -1, but now it's being squared. You'll also notice that I keep those negatives in parentheses. That's the actual -1 being raised to that power. That's important. What I do with exponents is one level below what I see. 2 times 2 is 4. I don't change the 3. I don't have to change the 3. It's included in that multiplication. And y to the 6. What I do with exponents is one level below what I see. Man, I hope that makes sense. If it does, you're gonna win so much in life in this video. It's gonna be awesome. Now we do a little bit more work. I know that 3 to the 4th is 81. Negative 1 squared. Negative 1 times negative 1 is positive 1. We get 81 y to the 6th. Positive 81 y to the 6th. That's cool. I hope that you can go through and try these on your own in just a little while, see if you can get them done. The last one, you can distribute that exponent, but you can only distribute it across multiplication and division, not addition, subtraction. So we cannot distribute below 2 levels, or below 1 level. We cannot go to 2 levels. So when you see that exponent, go, I want to distribute that. Absolutely you can, across multiplication and division, not across addition, subtraction. So how we deal with this? Create that as a factor. That's x minus y to the first power. That's fine. Now we can distribute that 5 across division. When we distribute it across division, remember that as we distribute, we're taking exponents to exponents. So distribution causes this us to use that power rule. It says, well, you're having an exponent raised to an exponent. So yeah, I'm going to get x minus y to the, let's see, I'm seeing exponents one level below is multiplication. 1 times 5 is 5. And to the division part, to our fraction, to the first, I'm raising that to another power. So I'm distributing the power. That raises a power to a power. That's an exponent level. 1 level below that is multiplication. 1 times 5 is 5. Notice why we write that power. It's very easy for people to not write that and go, oh, you're multiplying 10. It's really common. That's why one of the reasons why we have that, to show that no, what you're really multiplying, you are multiplying, but exponent rules only apply to exponents. You have to show those exponents. Maybe simplify that and give me 32, but after that, that's about it. That's all we can do. We cannot distribute exponents across addition, subtraction. That's 2 levels below. It does not work. It never works. So anyhow, I hope that this makes sense. I hope that you understand the interplay between the power rule and how to distribute with it. So when we're distributing, yes, you can distribute 1 operational level below what you have. If you have exponents, it's across multiplication, division. When we do it, we're taking exponents to exponents. Do 1 level below that, multiply your powers. Do not ever multiply your bases times an exponent, ever. I'll see you next time. We're going to just do some practice next time. So next video, I'm going to put some kind of more difficult problems. We'll call it Exponent Rules with advanced problems. And we'll practice doing this on some harder concepts. We'll put everything together. So I'll see you for the next video when we talk about some more advanced ideas.